Determining a molar mass is going to sound like initially a totally new concept, but it's not. Turns out that molar masses and formula masses are very connected. So in order to do well on this topic, you'll want to have looked at compound formulas so that you can look at a formula and figure out, okay, this tells me about how many elements there are in the formula and how that all works. Molar mass is very related to the formula mass. So the formula mass is the sum of the atomic masses of all the elements in the compound. And it's given units of atomic mass units when we're talking about a molecule or an atom. The molar mass is the same number, which is fantastic. You already know how to calculate formula masses, so molar masses, you just swap the units. And instead of saying atomic mass units, now we say it's the number of grams per 1 mole of substance. To do this, we need the periodic table, because just like when you were calculating formula masses using those average atomic masses, we're going to use those to calculate molar masses. So let's say I needed to calculate the molar mass of carbon dioxide. I would need the molar mass of, we'll just put mm, of 1 carbon, which equals 12.01 grams per mole, and of the molar mass of 2 oxygens, which equals 2 times. And now here's where we get into what a former colleague of mine used to call the sloppy rule, which is, here's my mass for oxygen. It's big. It's precise. Well, not really precise, but it's got a lot of numbers and a lot of decimal places. And what you will generally find in this class is that we will round to the hundredths place. So right there. So we will chop off everybody else and round if needed. So oxygen's molar mass becomes 16.00 grams per mole. And then I will take my 12.01 grams and my 2 times 16 and I will add them together. And when I do that, I will have the molar mass of carbon dioxide. So 12.01 plus 16 times 2 gives me 44.01. So this is 44.01 grams per mole of carbon dioxide. What is the formula mass of caffeine? It has a formula of C8H10N4O2, which is a lot of stuff there. So we go back to our periodic table. We look up the molar mass of carbon. We have 8 carbons. Let's make that black. We have 8 carbons, which means I have 8 times 12.01. And I have 10 hydrogens, which is 10 times 1.01. And 4 nitrogens, which is 4 times 14.01. I really like 0.01s, don't they? And 2 oxygens, which is 2 times 16.00. I sum all of those together, and that will be the molar mass of caffeine, which comes out to be 194.22 grams per mole. Now, I added this up using the periodic table that I had on my desk, and then I checked Wikipedia, or I Googled the molar mass of caffeine just to double check. And when I Googled it, it told me that the molar mass of caffeine was 194.19 grams per mole. So what you find here is that we don't exactly agree with one another, that we're off by 0.03. On a chemistry assessment, we're not worried about that kind of difference, because this is merely a difference of how did someone round, how many significant figures did they carry past the decimal place. I'm carrying 2. The people who calculated this number might have been carrying more, and so I may have ended up rounding differently than they did. Let's look at the formula mass of calcium phosphate. In this case, I have 3 calciums, I have 2 phosphorus, and I have 8 oxygens. And once I have added up all their molar masses, so it's 3 times 40.08 and 2 times 30.97 and 8 times 16.00. When I add all of those together, I get 310.18 grams per mole. The molar mass is going to serve as a conversion for us. So I just want to draw your attention here to the fact that this is really the same as saying 310.18 grams Ca3PO4 is equal to 1 mole of Ca3PO4. That's a unit conversion, which means we can write it as a fraction, and we can flip it, and we can use it and set it up to convert between grams of some substance to moles of that same substance. Notice here that all of these I'm setting up as equal to 1 mole of substance. That goes back to our definition of the molar mass, which said it was per 1 mole. So whenever you're calculating molar masses, they are always per 1 mole. It does not matter what else the problem is asking you. The molar mass of a substance is always per 1 mole.